Here are some more examples of finding the perimeter area of a figure on a coordinate plane. I'm going to use the method where you draw a rectangle around the figure and then find the lengths of the sides by using Pythagoras, and then find the area of the figure itself by finding the area of each of these triangles and subtract that from the total area of this rectangle. So if you look at this one, you want to make a rectangle around this, surrounding this rectangle inside here, and then give the dimensions of each of these triangles. So this is a 2 by 2. So 1/2 of 2 times 2 is 2. So the area of this purple triangle is 2. And then 3 times 3 is 9, and half of that is 4.5. And this is 2 by 2 again. So 2 times 2 is 4, and 1/2 of that is 2. 3 times 3 is 9, and 1/2 is 4.5. So, and the way I found these sides is to 2 squared plus 2 squared, which is 4 plus 4 is equal to c squared. So c squared is equal to the square root of 8. So just to demonstrate how I did that, this side right here, how I found this side, I did 2 squared plus 2 squared equals c squared, and I have 4 plus 4 equals c squared. So 8 is c squared, and then take the square root. So c is the square root of 8. So this is the square root of 8. This side also square root of 8. It's a rectangle with equal sides, and then did 3 squared plus 3 squared, which is 18, and this side is square root of 18, and so is this one. So the area, this is actually a square here, 5 by 5, so 25, and then I subtracted out each area, each triangle area. So 25 minus 2 minus 4.5 minus 2 minus 4.5, and 25 minus 13, the area is 12, and then the perimeter, just adding up the sides, that is square root of 8 plus the square root of 18, square root of 8 plus the square root of 18, so 2 square root of 8 plus 2 square root of 18. And on the check for understanding, you just put this on the calculator to find the approximate value for that. Number 2 is this quadrilateral here. So I surrounded it with a 5 by 4 rectangle. And so to make this right triangle here, I cut in these 2 right triangles, I made this little square here. So all these are right triangles here, the purple ones, and then this little square also. So to find the area of each triangle. The area of this triangle is 2, this one 1.5. The area of this small squared is 1. The area of this triangle is 1. Area of this is 2.5. The area of this whole thing, the purple rectangle, is 4 by 5. So the area is 20, and then subtract out each of the triangles in that small square, and you get the area is 12. And then to find each side here, use Pythagoras. So adding those together to find the perimeter. And then same thing with number 3. Surrounded the quadrilateral there with a rectangle, and then made right triangles. And this one, I had to make the right triangles by making this rectangle. Same thing down here. So 1 by 2, that area is 2. Same thing here, 2 by 1, that area is 2. And then this is 8 by 1. So 8 times 1 is 8, and half of that is 4. This is a 2 by 7, so 2 times 7, 14. Half of that is 7. This is 9 by 2. 9 times 2, 18, and half of that is 9. And 6 by 1. 1 times 6 is 6, and half of that is 3. So the area of this rectangle is 8 by 10. That's 80. And then subtract out the 4 triangles and the two small rectangles there. You end up with 53. The perimeter, the way I found these sides was use Pythagoras. So for example, 1 squared plus 9 squared. This is 2 actually. So 2 squared is 4 plus 9 squared is 81 plus 4 is 85. That's the square root of 85. That's how I found the other sides too. And the perimeters just add up those 4 sides. And then number 4, I drew this rectangle here. It's 7 by 12. There's 1, 2, 3, 4 right triangles, and then this small rectangle here. That's 2 by 1. Find the area of each of these triangles. 12 times 7 is 84, and then subtracted out the 4 triangles, and then the 1 small rectangle here, ended up with 56.5. And then finding these sides of these right triangles, use Pythagoras again, and then added them together. On the check for understanding, you're going to put this on the calculator and find the approximate value for that. And the next page is a hexagon. Drew a 5 by 4 rectangle around there. Each one of these triangles has an area 4. The area of this rectangle is 20, so 20 minus 4 is 16. And then found each of the, so these 2 sides you just can count, those are 3. And then this is, each of these are 1 by 2, so 2 squared plus 1 squared is 5. So every one of these here, these other 4 sides are square root of 5. So adding those together, get 4 square root of 5 plus 6. And I think these were the 2 that were illustrated in the county video. So if I make this 100% here. So illustrating it with the rectangle method here. So make the rectangle around here. And then this side is 10. This side is square root of 40. I think I might have done this same triangle in the other video. So the perimeter is 10 plus 10 plus the square root of 40, which is 20 plus the square root of 40. And then the area of the triangle is 1/2 10 times 6 is the height here. The base is 10, the height is 6. So 30. Or you could find the area of the rectangle, which is 60, and then subtract out these 2 triangles here. And you still get the answer 30. And then this one here. Same idea, drew a rectangle around it. And in the video, I think they used the distance formula to find these 3 distances. And I used the same strategy as number 2 here. And then the area of this large rectangle is 8 by 13, which is 104, and then subtracted out each of the triangles here. So this is 5 times 13, 65. Half of that is 32.5. So this area right here, if I were to write it in, is 32.5. Let me type it. So this area is 32.5. Let me make it smaller. And this one is 8, which is 2 times 8 divided by 2. And then 11 times 3, 33 divided by 2. All right, I'm going to stop the video here. If you show up for office hours, then I can explain these more in depth. And then if you have questions, you can ask me. But just the overview of how to do these, I would use the rectangle method. Use Pythagoras to find the sides of these triangles, and then to find the area of the rectangle, subtract out the triangles, find the perimeter, just add the sides up after you use Pythagoras. Or you can use the distance formula to find each of these. But I think that's much more, not complicated, but it's a little bit more work using the distance formula. I'm going to stop the video here, and like I said, check into office hours if you have any questions.